Okay, so this is the explanation for quiz 2, chapter 1 to 3. Okay, let's look at question number 1. Okay, if you see radioactive, okay, half-life. Okay, so radioactive, the reaction order is first order reaction. Okay, then determine the rate constant of Y. Rate constant, the symbol is K. Okay, now let's solve one by one. Okay, so if half-life for first order, the formula is ln 2 over K. Okay, and remember half-life, so you have to write T half. Okay, substitution 1 mark. Okay, and then finally, final answer. Okay, many students didn't get any mark because one thing, you didn't label the unit. And also remember, because this is first order reaction, so the unit for first order reaction is per time. Okay, now let's go to second one. Okay, determine the time needed for 10% of Y to decay. Okay, many students misunderstood 10 means that it decays to 10%. Okay, so this is incorrect. It means that 10% of Y to decay means in the end, Y equals to 100 minus 10 because 10% decay to decay. Okay, so because this is a first order reaction, so we can assume the initial is 100. Okay, so the remaining is 90. Okay, use the integrated rate law and then you will get your answer. And don't forget your unit. Okay, because the half-life is given in year, the unit, so you just put year. You don't have to change it to second or minute. Okay, next part is prove the order of decay of Y by using linear graph method. Okay, linear graph method means you need to use the integrated rate law again. So what we do here is, remember, Y equals to mx plus c. Okay, so our Y is ln Y. Okay, and our m is K, time is T. Okay, and then the C is initial. And then it's negative. Okay, when you change it. Okay, so the problem with this graph is labeling of axis. Okay, so it should be ln Y. Okay, and then time, remember, is given in year. So you need to show the unit as well. Okay, for this one, you can just label ln Y initial. Okay, then this part, you don't have to show it, okay, because you didn't say that it is 10% as well. Okay, if we show here means that it is 0. Okay, so now we move on to the next one. Okay, the decomposition. Okay, given rate constant K1, temperature T1. Okay, then activation energy EA. Okay, and then this give kilojoule per mole. So means that kilojoule needs to times 10 to the power of 3. Okay, so you just use the expression straight away. You don't have to derive again the Arrhenius equation. Okay, just use this formula, substitute, then remember temperature must be in Kelvin. Okay, then you see here is correct. Okay, because initially we have 10 to the power of 2 and then kilojoule means 10 to the power of 3. Okay, however, you've forgotten it is negative 13. Okay, and then unit is correct. Okay, so your final answer is incorrect here. Okay, now we go to calorimeter. Okay, for calorimeter, okay, heat capacity, capital C here. 1 liter of water means 1000 ml, also equals to 1000 grams. So we know if we have mass of water means mc delta T. If we have capital C, C delta T. Okay, temperature change is given. Okay, so the first clue that we have got is Q equals to MC delta T. Okay, this is the first clue. Okay, so you can start to calculate and then remember, substitute, and then this is 1.18 specific heat of water. Remember your unit. Okay, most students always forgotten to write their unit. Okay, now we have solved heat release. Okay, but how to find the mass? So we need to find number of mole. Okay, so how do we get number of mole? Okay, let's look at here. This is a combustion reaction, okay, because we know it reacts with oxygen and it produces carbon dioxide and water. Okay, so means that combustion of 2 mole of C5H10 will release 3000 kilojoule of heat. Okay, however, okay, here we can see that the student is using H2O, means you are referring to heat of neutralization, okay, where it is not. Okay, this is heat of combustion, so you don't have to refer to number of mole of water. Okay, but however, after you have calculated the ratio, you still got the number of mole of C5H10 correct. So you also got the correct mass for C5H10. Okay, but you should be just doing 3000 kilojoule, okay, is released by 2 mole of C5H10. Okay, so here we have 31.75 kilojoule, so it is released by 0.02116 mole of C5H10. Okay, so this is the correct stoichiometry. Okay, now the next one we move to Hess law. Okay, Hess's law. Okay, first of all, it says determine the heat of formation. Okay, determine the heat of formation means it must be from element to form 1 mole of compound. Okay, most students didn't memorize the definition, and the emphasis for heat of formation is the formation of 1 mole of compound. Okay, so what is asked for is heat of formation and also writes the thermochemical equation. Okay, so for this question, okay, HNO3 means it has hydrogen element, nitrogen gas element, and also oxygen gas element. Okay, so let's look at the first thing that I would write. Okay, I will write this first. Okay, and then hydrogen, I just need 1, so it is half. Okay, nitrogen, I need 1, so it is half. Okay, oxygen, I need 3, so it's 3/2. Okay, so this is the first part that I would write down. Okay, then I will find out how much is the enthalpy of formation. Okay, then in order to get this, okay, you need to do something to the equation, the reaction equation given. Okay, let's look at HNO3 is on the right hand side. Okay, so this one is on the right hand side. Okay, however, this one has 2. We don't want to have 2, so we will divide by 2 in order to get 1 mole. Okay, next one, let's have a look. Okay, the other elements are all on the left. Okay, so hydrogen is not on the left, so I have to reverse it. Okay, become left. So if I reverse, then the sign must change to positive. Okay, and then another one, hydrogen is half. So means here I need to multiply by half. Okay, Now hydrogen is done. Let's look at nitrogen. Nitrogen is on the left. Okay, so this nitrogen is also on the left. Okay, but we need to have half. So this one also needs 2 times half. Okay, so after that, we need oxygen. Okay, but oxygen appear 1 time, 2 times. Okay, so let's see whether we can balance the oxygen or not. Okay, so you can see here she has already rearranged all the equation. Okay, so just cancel out all that is all that other same. So the remaining will be nitrogen, hydrogen, nitric acid product. Okay, then you change it to, you have oxygen. Okay, so in the end, when you simplify, you will get 3 over 2 oxygen. Okay, then after that, you can start to calculate by adding all the enthalpy. You can label them 1, 2, 3. Okay, then don't forget it's per mole because it's specifically to form 1 mole of product. Okay, then we need to write the thermochemical equation. Okay, for thermochemical equation, remember you must write down, make sure that this is only 1 mole phase. Okay, then for thermochemical equation, we only write down the unit kilojoule, not kilojoule per mole. Okay, and remember to label positive because positive means heat is absorbed. Okay, now next one. Okay, if we look at this question, many students tends to always remember that Cu always too positive. Not necessary. Okay, let's look at the information given. First, ionization energy. There is no second ionization energy, meaning that we only have Cu plus. Okay, and then Br minus. So we will only get Cu Br. Okay, so this is correct. Okay, but however, this part is wrong because must remember for element, okay, bromine is in liquid. Okay, then after that, you need to construct the Born-Haber cycle and label all the enthalpy. Okay, so remember to put the symbol triangle as well. Okay, so what is missing here is you've forgotten that enthalpy of formation, negative 104.6 kilojoule per mole. Okay, because of that, so your answer is incorrect. Okay, it should be enthalpy 3 should be equals to, let's say I put here enthalpy 6. Okay, enthalpy 6 minus enthalpy 1 until enthalpy 5. Okay, because of one careless mistake, so the calculation is incorrect. So for here, remember it is until Cu positive only. And then remember to write plus. Many students forgotten to label plus here. That's why they didn't get the marks. Okay.